We're here for our career overview on opportunities in the field of blockchain. My name is Stuart Creek. I'm with Simplilearn, and I'm here with Dr. Sandeep Shukla of IIT Kanpur and the National Blockchain Project. We'll be talking a bit about careers, and then we'll share with you information about a certification program that the Institute offers. So, Dr. Shukla, would you like to introduce yourself a little bit?
Yeah, so thank you, Stuart. So good evening, everybody. I am Professor Sandeep Shukla. I am actually a professor of computer science and engineering at the Indian Institute of Technology in Kanpur. I am also the coordinator for the National Blockchain Project, which is a flagship project by the government of India for using blockchain technology, decentralized ledger technology for e-governance solutions. I'm also a coordinator for the Interdisciplinary Center for Cybersecurity and Cyber Defense of Critical Infrastructures, which is called the C3I Center. And also, right now, I am one of the program directors for the C3I Hub, which is a technology innovation hub in cybersecurity. So my research interests are in cybersecurity, mostly focusing on cybersecurity of critical infrastructure, and also the blockchain and the decentralized ledger technology and Web3 technology, this kind of stuff, but more focusing on the security of these technologies. And my education was in India. I did my bachelor's degree from Jadavpur University many years ago, more than 30 years ago now. And I did my master's and PhD is actually from State University of New York at Albany.
Great. Thank you for that. And let's talk about blockchain, which is one of your several particular areas of expertise. Can you kind of I don't want you to go into the details of what's in each of the block diagrams here, but can you just give an overview to our audience members of what blockchain technology is?
Right. So, so in most of the technology today, be it a financial system like a payment system, or if you think in terms of other, server-based enterprise applications, these applications actually have multiple different components which talk to each other and keep track of various data that they actually keep in their own individual silos. And what that makes things are that things become very inefficient. For example, in payment systems, if you are going to look at UPI-based payment system, actually there are multiple banks involved and multiple intermediaries involved, and they have their own ledger of information about various accounts and various identities and so on. And what makes, so that makes things rather inefficient. And also, these things are kept in these silos under the control of those individual entities which are involved in your payment, or in case of a property registration, the various offices like Department of Land Registry, the Registration and Stamps Department, and so on. And therefore, there is little transparency, and there is very little proof that nobody's tampering with that data. So what blockchain technology brings in is a shared ledger across multiple different players. And this ledger is what we call a decentralized and distributed ledger, because the ledger is copied or replicated across all these entities which are involved. And more than that, anybody who is interested in keeping a copy of the ledger for the sake of transparency and for validating that whatever is happening on the ledger is trustworthy, they can actually share this ledger across all the different computers or what we call nodes. So this ledger structure is usually created using some blocks of data, and these blocks actually are connected to each other with cryptographic hash, what we call hash pointers. And without going into the details, I can say that these blocks actually are dependent on each other in the sense that one block, the block number n, the hash of that block is connected to the block number n+1 through a hash pointer, and block number n+2 is connected to n+1 with a hash pointer. And therefore, any change in block n would necessarily require change in block n+1, block n+2, all the way down to the very latest block, which makes it very difficult for a single entity or single attacker to actually change anything in one of the blocks. So since the ledger is now a sequence of blocks, therefore it is difficult to change the ledger. So that's what we say, that the blockchain is actually an immutable, or rather tamper-proof ledger. And so any data that goes in there stays there with a very, very high probability, without any single or a couple of people trying to collude to actually change anything in there. So that gives you trust, because you have multiple entities which are maintaining the copies of the same ledger, and each of these copies cannot be tampered with without an immense amount of computational power or immense amount of other kind of power, like money power. So therefore, it gives you a sense of trust. It gives you a sense of transparency. It also gives you a sense of breaking the barriers between silos, which brings efficiency. So that's what I would say. In general, the way I understand blockchain.
Thank you. And I think that last point is really the part that makes it such a valuable tool for applications, in that the first part, the technology that makes it immutable and makes it secure, makes the tool useful from the technological point, but the fact that it breaks the silos and crosses different organizational boundaries securely is really what makes it useful in applications. If you think about transactions that you have with your bank today, where you have to ask them for information, they update the information, there's a back and forth. You can conceive of a blockchain type implementation where all of this is happening, and all of the records involving you are transparent, so that you don't have to query that. It's embodied in the blockchain.
Correct.
Yeah. So brief history. This is looking back at how the technology came about, and it's just a couple of points along the timeline. But back in 1991, this is where the concept of a blockchain secured by cryptography, where you have to use very complex and secure methods, mathematically secure methods, to generate a block and attach it to the chain. That's where the idea first came up.
Right. So this was done by the scientists from Belcourt in New Jersey.
And can you take us through, some of these other points?
Yeah. So until around 2008, this technology had some bits and pieces, like all the individual elements of blockchain technology, like cryptography, the hashing technology, the pointers, hash pointers, the idea of distributed computing, everything was there, but nobody actually put all of these things together until in 2008. There is a person who called himself Satoshi Nakamoto, but nobody knows who he was. He
Yeah.
proposed this blockchain infrastructure for secure peer-to-peer transactions without need for trusted third party. And this is at the height of the 2008 banking crisis, the financial crisis. And it seems like at that point, from his writing and some of the strings that he had put in the original Bitcoin implementation, it seems that he was kind of trying to say that the banking is sort of not something that people should trust, and therefore they need a system of trustworthy way of accounting, transfer of value and storage of value in the form of a cryptocurrency. And that's where the Bitcoin, the idea of Bitcoin came about. And in 2009, he created the first implementation of a blockchain in the form of Bitcoin, and he mined the first Bitcoin block. And that's how the Bitcoin started, as a first cryptocurrency blockchain.
Yeah.
However, Bitcoin was quite limited in the way you can, automate transactions. There were a couple of ways to automate transactions in the Bitcoin blockchain, but not a whole lot, because Bitcoin did not have a language for expressing complex transactions. And that's where in 2014, the Vitalik Buterin, he actually came up with this Ethereum blockchain, which had this advantage that it not only was a cryptocurrency blockchain, but also it had the ability to execute arbitrarily complex programs. And he called them smart contracts. So given that we can do arbitrary complex programs, execute arbitrary complex programs in a blockchain, it allowed us to do very complex transactions and automate them. Like, so I can program that, I want to pay this amount to this person, and then I want to do with the rest of the amount, I want to do this, and I want to actually put some maybe some remuneration for that, and this kind of complex logic you could actually put in smart contracts. And that actually kind of this is what we call blockchain 2.0, because Bitcoin, if you consider Bitcoin as version 1 of blockchain technology, then Ethereum with its smart contract actually gave rise to what we call blockchain 2.0. Now, the difference between Bitcoin and Ethereum is that Ethereum gives this programmability, which makes it actually arbitrarily powerful. In fact, we call it a distributed computing system. And but the Ethereum is still anonymous, pseudo-anonymous, and the Ethereum is still based on the permissionless paradigm. That is, anybody can join the Ethereum network and have complete visibility into the ledger. But enterprises did not necessarily want all their ledger information to be out in the open. They might share it across multiple different entities that they partially at least trust, but they did not want it to be open to public. And that gave rise to the notion of the permission blockchains. And that's where Hyperledger project was formed in 2015. So that we, since then, the blockchain 3.0 kind of started.
That's a really fascinating history, because you go from an interesting technology to making it useful across a certain set of problem domains, and then, you know, when you find the gap in those problem domains, the other problems that don't fit that solution, then it
Yeah.
extends again to the Ethereum, the Hyperledger, I should say, for solving those. And I'm going to put a message into the chat just to remind everybody for questions. We're going to be taking those toward the end of the session, about 2/3 of the way through the session. So I'm going to put just a reminder in the chat for everyone to put your questions in the Q&A box in Zoom. And we'll also be talking about a bonus that you receive for attending this session this evening. So here's some statistics that we came up with about blockchain. And as you've mentioned, you know, it started with cryptocurrency, but it's doing contracts, supply chains, almost anything you can think of. There was talk during the pandemic about blockchain-based supply chains to control the expiration date records for vaccine supplies. So kinds of problems where information has to be secure, immutable, traceable. It's all sorts of problems that can be solved with this technology. We're just at the infancy stage, aren't we?
Yes, so I think that see, actually the journey of blockchain started in 2008, and it mostly remained in the idea of cryptocurrencies, especially Bitcoin and Ethereum and few other what we call altcoins for a long time. But very recently, you know, around 2017-18, people started looking at this as a decentralization alternative to centralized services. Like people started getting very concerned about the centralization of information by companies like Facebook and Google and so on. And they also the way that people get paid, for example, for creating various kinds of intellectual properties like videos and music and pictures and so on. People started getting very concerned that all of that stuff is now being centrally, controlled by these centralized systems like Facebook and so on. So there was this notion of decentralization was taking a root among people, and that led to this notion of decentralized web, or what they are now calling Web 3.0, which may or may not be the appropriate name, but that's where the idea is that everybody should have ownership or sovereign ownership of their material, the material they create, the data they create, and still have a way to share them. And also there should be ways to monetize their creation without having to rely on something centralized like Facebook or Google, etc. So that led to this notion of Web 3.0, which is taking taking root as we speak. But there is also there is a huge interest in the governments and in the enterprises to actually, as I was saying earlier, is breaking the silos and making things more efficient, more transparent, and easy to actually create conduits for sharing information required for complex multi-stage information processing. And that also is giving rise to this idea of using blockchains for supply chain management. In the time of pandemic, we were also talking about cold chain management, like the vaccines are actually being transported through multiple different intermediaries, and whether the temperature is being properly maintained, etc. Tracking all those, tracking global shipments, doing various kinds of e-governance applications such as identities, self-sovereign identity, then property registration, certification of various kinds, like school living certificates or driving license or COVID vaccination certificate. Using blockchain to actually create these systems is gaining a lot of attention, and that is leading to this notion of Web 3.0. So that's that. So as you said, that this is the beginning, and hopefully this beginning will actually accelerate as we go forward. There is a lack of regulatory clarity in some jurisdictions, and also there is a lack of manpower to actually create these systems. So as we actually go forward, these things will get better, and I think then we'll see a much better growth that we are likely to see. So
Yep.
here we were saying 67.3% annual growth, but that may accelerate, beyond that time frame. It's actually right now in kind of like in a little bit throttled because of the regulatory uncertainties and lack of manpower.
Yep. Where if you look at the expression, the hockey stick graph, where things take off slowly and then they reach an inflection point and take off really fast, we're still, I think, in the bend of the hockey stick. Yeah.
Right.
And so it's really top of mind for people in business and technology, but also in general business. You can see here, there are quotes from different um, sources. The European countries talking about blockchain and the growth of jobs in that sector in the European Union. Um, there's Crunchbase, which is a technology blog and database of employers and jobs and startups. That is talking about blockchain as one of the hottest tech areas, employment areas. Um, SD Times, Software Development Times, talks about blockchain in enterprise and how it's extending into those areas. And then this last one is the NASDAQ, which is the North American stock exchange for small companies. So NASDAQ doesn't actually mean small companies, it just means it's a separate independent stock exchange where transactions are done more or less autonomously rather than the big Dow Jones Industrial Average, Wall Street trading, and that type of thing. NASDAQ um, lists a number of companies in the technology sector, and so it's a business um, area that looks at the business implications of technologies and advises member companies. So NASDAQ is talking about using blockchain technology in the area of title fraud in real estate transactions. So um, that's actually, by the way, in the United States, that's become a big problem where there are people who can go into public databases, find out information about your property ownership, and because of the way property transactions are recorded in most places in North America, they can actually record that a sale of your house occurred without you knowing it. So they can claim that they bought your house and have that deed recorded. And again, that's because the records are not secured in the same way that blockchain technology would, and they would not be able to do that under a blockchain regime. So this is where you see that blockchain has gone from, oh, it's interesting and people are trading Bitcoin and all of that, to now people in industry and technology and business understand that this technology exists and they're looking actively for ways to use it. Is that a fair characterization?
Yeah, so actually, interesting about this title fraud thing. So this is the same situation in India, because there are two parts of selling a property in India. For example, one is you have to create a deed, what you call title, I guess, and you have to register that deed with the Department of Stamps and Registration,
Mhm.
and which is totally independent of what is called mutation, where the property gets into your name. And these two are systems in two silos, and therefore this somebody can actually sell me the Taj Mahal, without any problem. He can just register a deed where he's selling me the Taj Mahal. Nobody's the registration office is not there to actually look into whether that Taj Mahal actually ever belonged to me, belonged to him or not. So this that's what this blockchain, what blockchain does is that it helps to actually bridge these silos in a way, so that you have transparency, and you also have immutability. So therefore you can have a more incontrovertible proof that something belongs to somebody. And we did actually work with the government in one of the states in India, in Karnataka, to actually do this thing on blockchain. So we actually did implement a blockchain-based property registration in the state of Karnataka. So yes, so these are some of the usage of blockchain technology in that is emerging.
Yep, that that's fascinating, and I'm hoping that that application comes, worldwide soon, because it's that's just one example of a problem that exists so many places around the world that really needs a solution. So here's some people, uh, UI blockchain. I'm sorry, shouldn't say UI blockchain, just blockchain. Um, the These are people in different leadership positions, and they're talking about what blockchain is and does from their perspective. So you have Adam Draper talking about how blockchain does this one big thing, which it replaces third-party trust with mathematical proof that something happened. So you don't need somebody else to certify this happened. The mathematics that go into the creation of the hash links actually becomes your proof, your immutable proof that this transaction or this event occurred. So
Right. Yeah.
that's a go ahead.
Yeah, so you know that India has introduced the central bank digital currency.
Hmm.
Central bank digital currency is going to be eventually on blockchain. And there right now, when you actually give somebody money, you have to trust a third party to actually, especially when you are doing it through banking, for example, not cash, but if you give money through banking, you have to trust a third party for actually eventual settlement of the actual transaction. Whereas in blockchain, you can actually mathematically, like you can actually create a what we call zero knowledge proof that a transaction actually took place,
Yep.
right? So that is what I guess it means as replacing third party trust with mathematical proof.
Yep.
So
Oh, I was just going to say that using that example, when you talk about cash itself,
yeah,
for most of the history of the United States, all of the currency bills, paper currency, were printed on the same type of material. Um, the only thing that was different was the pattern design printed on it with the serial numbers. So counterfeiting has always been a big problem. It wasn't until a couple of decades ago that the Federal Reserve issues currency started doing things like putting in different types of identifying embedded plastic strips into the different denominations and so forth. But even so, you can still um, counterfeiting can be a big problem. It's still possible to fool most people with a counterfeit bill. And that's the kind of thing where you have to rely on not just third-party trust, you have to rely on the trust of everybody who's touched that bill until you got it, that it's real. And that, in fact, the law in the United States says if you're the one who has the bill when it's discovered to be counterfeit, then you're the one who's stuck with the loss. So you can't really, you may be able to trace back people who handed the bill to you, but you're not going to be able to do anything to get reimbursed, for example. So this is the kind of trust issue that blockchain replaces with technology and the mathematics. So the blockchain, according to William Mudgar, is a shift in power from the centers to the edges of networks. That really ties in right with what you've talked about, the silos of information.
Right. So, I mean, no, first of all, right now everything, Web 2 is a very centralized system. Like if you are going to let's pay your tax, you are dealing with the servers of the IRS or the income tax department, or if you are going for your verifying your identity through Aadhaar, you are going to the other data center to and you are at the mercy of those central databases. Or if you are going to Facebook, you are going to the central servers of Facebook. Whereas if you are going to use blockchain, then the data is actually across the network and replicated and distributed and decentralized. And that's what he means by shift of power from center to the edges of the network. And you might have a much more sovereign control on the data that you do not have in a centralized system.
Yeah, that's an interesting example because I have a driver's license which is issued by the state of California, and the control of all of that information and its validity all resides with the Department of Motor Vehicles, which means that if their computers happen to be down at a given point, or if their offices are closed, that type of thing, a lot of my access to that information or my control over it is denied to me. Whereas you can imagine a blockchain solution where that capability is never locked up by one single entity.
Yeah, not only that, I mean, the California Motor Vehicles Department might actually share your information. Only thing stopping them from sharing your information is the law. But in blockchain, you can actually make it technologically impossible to share that information without your consent. You can design the system in such a way. So it's one is to trust the law and the legal authorities to enforce the law, and another is to actually make the technology work for you to make it impossible, right? So that would be the difference.
Yeah. And then as the CEO of IBM was saying, anything that you can conceive of as a supply chain, any type of chain of transactions or any type of chain of control can be improved through blockchain. So that's an interesting quote there. And then blockchain, CEO Fidelity Investments, which is a large financial firm, blockchain technology isn't just a more efficient way to settle securities, stock transactions. It will fundamentally change the structure of the market, even, as you said, the architecture of the internet itself when you talk about Web 3.0. So
yeah. So I think that these are very point on quotes. The supply chain, for example, as I was saying that right now Walmart, for example, Walmart actually has implemented with IBM Hyperledger a system through which they actually can tell from which farm in another country like Mexico some produce has been originally harvested and where it's been through its entire cycle journey to the supermarket. So if
Yep.
anything goes wrong, anything needs to be recalled because it turns out to be contaminated, then they can actually find the way back all the way to the origin, so that they can pinpoint which farm the problem actually originated from.
Yep.
So this is the kind of thing that they have been doing, and this is all because it's not like all this technology is actually not rocket science. It's technology that actually existed before, but never thought of uh, in a way that blockchain has brought this things together.
Yeah.
So this is something that is not impossible to do, or not something inconceivable to do, but blockchain gives us the handle onto the on the way to actually get these things done.
Yeah. That's kind of the story of human history. Was somebody who sees different pieces and puts them together in a novel way that together they form a solution that didn't exist before. And we talk about the skills one needs to work in the blockchain arena. Talk about go over some of these and how they relate to a career in blockchain.
Yeah,
What are the things you need to know?
so it depends on what you want to be in the space of blockchain in your career, because there are various kinds of things you can do. You can you can design a new blockchain technology like Bitcoin, Ethereum. These are some blockchains, but they have their own shortcomings. There is Hyperledger, it has its own shortcomings. There are many other ledgers that have come up in the last 10 years or so. So there are various ways. If you want to do all that, if you want to build new blockchain technology, then you need to understand. Obviously, you need to do a lot of programming. You have to understand, how to build systems with network. Because in blockchain, everything happens by network communication. You have to understand programming, you have to understand cryptography, and you have to understand how the distributed systems work. But on the other hand, if you want to actually, let's say, take a existing blockchain and you want to build applications that like the supply chain application, or a security application and so on, in that case, you do not have to learn the programming in the sense of learning C, C++, kind of, or Golang, this kind of languages, but you have to learn the language of writing smart contracts like Solidity, for example, or you can also write smart contracts in Go, and maybe also in Java, and in Hyperledger, for example, or in Rust, for example, in Polkadot, this kind of blockchain. So you have to learn programming to actually create applications on blockchain. But if you want to actually also do blockchain, architecture, the architecture requires you to understand software architecture, distributed network system architecture, but also you have to understand business process automation and business process flow and workflow, this kind of stuff. Now, if you want to go into the financial applications, then you have to understand cryptocurrency, you have to understand Bitcoin, Ethereum, tokens, how to create how to tokenize various kinds of assets, and how the token economics works on the blockchain. So you have to understand those things. And if you want to become a blockchain kind of like what we call evangelist, then you have to understand about consensus, you have to understand about tokenization, you have to understand about Web3 technologies, you have to understand the distinction between distributed ledger and blockchain, you have to understand hash graphs, you have to understand various things. So there are a lot of things. Depending on what you want to become, you require at least a subset of these skills. But you cannot start without having at least a fundamental in all these skills, right? So you have to have a fundamental set of skills, and then you have to hone your skills in a few specific of these technologies to actually grow your career in a certain direction. So
Yeah.
all these things listed here are actually basic fundamental concepts that you will require to know in order to become an effective blockchain professional.
Yeah. And then to talk in general about the T-shaped set of skills where the broad array of knowledge about an area is your horizontal bar, and then your deep knowledge of a particular area becomes the vertical. And so these represent the horizontal bar, and you can choose where in that you want to move into the vertical. And you also mentioned things like Solidity, Hyperledger, Ethereum. These are all different types of not only terms that people need to know, but they're actually underlying technologies and platforms, and they're used as different tools for different purposes. So people need to be exposed to those. Yeah.
Yeah, you need to get your hands a little bit dirty with all of these when you actually get started in blockchain. Then you might become a Hyperledger professional, or you might become a Solidity programmer, or Ethereum professional, or you might actually become a Bitcoin guru or something. But you have to get your hands on to get the flavor of each of these, and actually understand how each of these things work, how they differ from each other. Because there are very good ideas in each of these, and you might actually eventually use a combination of these in what you want to do.
Yeah. And it's not a matter of like someone like myself who's heard these terms and has some idea of what they mean. This is if you're interested in a career in this field, as the professor said, you have to get your hands on these tools and use them in different examples, projects, exercises, so that you know what they do and legitimately claim that you know how to use them. So that opens up a bunch of different potential career paths. I mean, you touched on this a bit earlier, Professor, but if you could go over.
I mean, blockchain developer is, where you actually develop a blockchain technology. Like, for example, one of the most successful Indian startup is actually a unicorn, which is actually being used worldwide, which is your, this company, blockchain company, a layer 2 blockchain company. They actually developed their own blockchain, layer 2 blockchain on top of Ethereum, and they're taking the world by storm. This is there are a lot of blockchain developers who work there. But when you design blockchain applications, like, you have to also design the front end. And the front end is actually where the users interact. Users don't need to actually necessarily use blockchain terminology if they want to do their property registration, right? Or they want to pay their taxes, or you're collecting GST through a blockchain-enabled system. So there, the front end, the UX, the user experience design, the web design, these are the some of the stuff that are, for that you need to know blockchain, because you are connecting to the blockchain, but you know more about web front end design, like React and Java, Node.js, and things like that. But you can also become a solution architect. So you may actually not do hands-on programming, but you understand blockchain, how it works, and what it brings to the table in terms of design efficiency, in terms of trustworthiness, in terms of immutability of data, etc. Then you can actually be a solution architect. Although it takes some time to become solution architect, because unless you have done some designs yourselves, you cannot be a really a very effective solution architect. But then also there are blockchains are actually applications also have a lot of code associated with it, like the smart contract code, right? So they actually have bugs, and therefore you have to find bugs in blockchain smart contract code, and then you have to actually do penetration testing, or you have to do testing, you have to do analysis of possible bugs and fix them. So that's the blockchain quality engineer that work on blockchain quality engineer. Then you have blockchain project manager who understands blockchain end to end, how it works, and what is involved in delivering a blockchain based Web3 project, but then do not necessarily do the programming themselves or do the solution architecture themselves. And then they actually do the management of the project, but unless they understand blockchain, they cannot really manage the people who would be designing the blockchain projects. So that's another one. And then there are legal issues in blockchain, the compliance issues, the jurisdiction-based various kinds of regulation issues that might actually come, for example. So those kind of things have to also, there are possibilities there.
Yeah, and these are all, some of them are things that you can do soon after you gain a set of skills, and some are the things that you evolve into as you continue your career and gain skills in other areas as well. So, but we're looking at the kinds of range of salaries where blockchain developers, who are kind of the entry level of the set of things that we looked at, you have the ability over time to ramp up to a salary of 15 lakhs. So, and these are current numbers from Glassdoor, India. And if you move into some of those other categories of work, like project manager or architect, of course, the upper limits are much higher. So here are just some of the companies that are listed as hiring today. IBM, Whiteforce in India, Collins Aerospace. Think about an industrial, mechanical-oriented company. That's probably the height of the category where you're working in aerospace systems, and EY Consulting. So these are kinds of places where you don't have to be looking just for jobs in the technology, data, information technology sector, I should say, but you can be looking across a wide variety of industries. Has that been your experience, Professor, the people that you've encountered through the program?
Well, actually, India has a very burgeoning Web3 community right now. In fact, it's probably more active startup ecosystem in this Web3 space, the blockchain space, decentralized finance space in India than many other countries, probably more than even the US. So I think that there is a good blockchain professional is very few. So it's very difficult to find the right fit for blockchain. So of course, one has to actually learn the technology very well and also get expertise in order to actually gain attention from those companies. But everybody is looking, and even we are always looking. For example, here at our projects. So yeah, I mean the blockchain is currently a very sought after area of employment.
Great. So that takes us to the end of this section of our webinar, and we'll take your questions now. And if you haven't put them in the Q&A yet, please do. I'll also look into the chat for questions there. And so we have this is the center, so I'm not staring off to the side. So we have a question: with adequate computing power, is it possible to attack the entire distributed system and erase blocks?
Yes. So if you have adequate, now the emphasis is on the adequate, right? So what is adequate? And it depends on the also the technology being used. Like in Bitcoin, for example, where proof of work is being used, there the computational power matters. And if you have really adequate computational power, you can do it. That has not happened to the Bitcoin mainnet. That has happened in a couple of derivatives of Bitcoin, little bit, not to the extent that blocks were removed or anything, but it has happened to, for example, Bitcoin BSV, for example. But Ethereum, for example, has now moved to proof of stake. There, the computational power will not help you. You have to have a huge amount of Ether to be able to do that, and even then, it's difficult the way the proof of stake is set up. So there it is not possible. So the question that whether there is enough computation power to actually redo the blocks or erase the blocks, etc., depends on the kind of consensus method that is being used in the blockchain. And if it is based on computational power, then yes, with adequate computational power, you might be able to do it, but it is going to be very tough.
We have someone who says, maybe says, I've learned Solidity, Ethereum, Hard Hat, a few front-end technologies. Is that a good suite of skills to get a job in this area?
Well, it depends on how well, what level of expertise or what level of practice you have in those. If you have them well practiced, you can actually crack the interviews. Yes, these are sought after. These are sought after skills. For example, there are a lot of companies, decentralized finance companies, who are based on Ethereum based smart contracts, NFT companies that actually do NFT, companies that actually are doing various kinds of DAOs or decentralized autonomous organization, or companies like Polygon, the one company I was talking about, the unicorn, Indian unicorn. That would be interesting.
Okay, and somebody asks if it's possible to enter into a course like this without a computer background. What are the kinds of things you need to have in order to be able to embark on this?
I personally would not encourage without a computer background, without a programming background, without a understanding of how software is designed, software systems work, at least how the web tool systems like a central client server system works. You might learn those things and then learn these. It's not like rocket science. You can learn those things, but there may be other courses that you have to take first. Otherwise, you can probably get more or less the idea about this course also without having the computer background, but then you won't be able to do much in terms of real contribution to the field, and therefore there will be a problem of jobs. So I would not say you take a computer, some programming and software design course first, and maybe then it might be a good idea.
Okay, that makes sense. Someone asks whether the concept of metaverse intersects with blockchain technology.
Yeah, so metaverse, actually there are blockchain enabled metaverse like Decentraland, for example. Although not necessarily all metaverse are decentralized. For example, the metaverse that Facebook was providing is a completely centralized single server based metaverse. But inside metaverse also there are a lot of things like gaming and selling of virtual lands and virtual properties, etc. These are done through NFTs or non-fungible tokens. So yes, there is a lot of intersection between blockchain technology and the metaverse idea. But metaverse can be without blockchain also, right? So metaverse is an independent concept that can be better, done with decentralization, but doesn't have to be.
We have a question.
Yeah, so Aadhaar is Indian central identity system. 1.4 billion people's identity is in a centralized data center. No, it is not based on blockchain. I wish it was, but it is not. And I think when it was conceived, it was in around 2006-7 time frame when blockchain wasn't there, and it has developed in a very rapid speed. So I don't think that they ever thought about doing it in blockchain. But if it was done now, I guess it would be a good idea to do it in the blockchain. But no.
Okay. Um, so we have a question about an application of blockchain. Could it be used to verify someone's educational credentials for a lifetime? So could it
Yeah,
be the
indeed, we have done that. In fact, the degree given by IIT Kanpur in last several years is on blockchain, which we actually developed here. The degrees given by NIT Rourkela, degrees given by AKTU this year, degrees given by IGNU, the Indira Gandhi National Open University, IIT Indore, they're all given on blockchain and they can be verified on blockchain. Yes, that is a big area of blockchain usage today.
Yeah, we had another application question about whether blockchain could be used to help with police compliance management.
Police complaint management, yes, but we have proposed that, but it's so FIR, the first information report that gets recorded at the police station when some incident happens. We actually propose that. It doesn't look like there is a lot of interest in that, because it seems like most law enforcement agencies, they retroactively go and change those things, even though legally they're not supposed to. But if the technology stops them from doing it, then they don't like it. So I don't think that they would ever agree to do that. But that would be a good use of blockchain.
Yeah. We have another question that kind of relates to what you just said, which is that who's responsible for regulation of the blockchain technology or applications of blockchain? Is there a central body, or is it?
No, so first of all, I think that government doesn't get into regulating a technology. They get into regulating specific types of applications. For example, financial applications that are blockchain based, like cryptocurrency or tokenized security or tokenization of virtual assets. These things are going to be regulated, hopefully. Right now, India does not have a regulation. Government is waiting for G20. India is currently the president of the G20, and they are pushing for a combined crypto virtual asset regulatory regimen, because Indian finance ministry believes that doing it unilaterally will not be effective. It has to be done in consonance with the rest of the world. So, I think that is where it is. So, yeah. But eventually the regulation will come for a specific regulator. For example, if it is related to banking stuff, then it will be the Reserve Bank of India. If it is related to securities, and then it will be the Security Exchange Board, things like that. So I don't think that there is a central technology regulation. There will be application level regulations.
Okay, thank you. I'm going to apologize in advance to people because we're not going to be able to hit all the questions, but want to ask a last couple of questions. One from an attendee who says, I have 20 plus years experience in telecom and the IT domain, would like to make a career pivot. So what is the scope for somebody in that position to take up blockchain and make a career pivot there?
Yeah, so that's an interesting question, because suppose you do that, you get trained in blockchain technology, but do you want to enter as a junior blockchain development position, or you want to be a system architect and so on? Depending on what you want to be, and if you want an equivalent position that compared to what you have now, then you have to learn a lot more than if you were to go into like become a Solidity programmer and becoming a some application developer, versus if you want to become more at the strategic level. So if you want to be the strategic level, your obviously your knowledge has to be a lot more vast and a lot more, I would say, not necessarily extreme deep, but it has to be all encompassing. Whereas if you want to become one particular type of application developer or something, then it has to be very deep, but not necessarily all encompassing. So, but it is doable. I mean, I personally started doing blockchain after many years of doing other things. Only in 2017, 18 timeframe, right? When so everybody who is right now doing blockchain has, blockchain wasn't there when we were students or when we were junior, faculty and things like that. So it is not inconceivable, but depending on how you want to, see your pivot, you have to do accordingly, that much effort.
Yep. And then I'm going to combine some questions into this last question, which is, we had somebody asking about becoming a blockchain developer from their undergraduate degree in computer science, and related to that, or what are the other prerequisites in terms of knowledge, and do you need a lot of mathematics background, for example? Can you come out of this
No, it's
from
again.
high school, from grade 12?
Yeah, so if you are doing undergraduate in computer science, hopefully you know enough discrete math and so on to understand basic cryptography, private key, public key cryptography, hash functions, and so on, which is what is required in terms of cryptography. But if you rest is, you have to understand how software distributed network systems work, and how data structures are formed and things like that. But eventually, if you want to be in the cutting edge of blockchain technology, then you have to understand a lot more mathematics. You have to understand zero knowledge proof, and you have to understand things like advanced cryptography, things like that, which will require a lot of mathematics. So depending on where you want to be in the blockchain technology space, immediately after you finish learning, you have to put that kind of effort and gear towards that, right? So if you want to become, the top-notch layer 2 blockchain system provider, you have to have a lot more knowledge than if you want to become blockchain application developer. So that's what I can say. Yeah.
Okay. So I'm going to ask the audience a question. You are all here because you're interested in careers in blockchain, and what has stopped you up till now from taking some type of training or certification in blockchain? Is it because you can't find a program that covers all the types of skills and tools that the professor talked about? Is it because you don't feel you'd have practical experience with those skills and tools at the end of the program? Is it because of the learning style, or is it because of your personal schedule? So I'll leave this open for another 5 seconds. Please get your answers in. I'll close the poll in 3, 2, 1. There you go. So the two main concerns are not feeling that you'd end up with practical experience with the tools that you'd be able to demonstrate your skills, and then not finding a comprehensive program. So I'm going to just briefly talk about the program from IIT Kanpur. Professional certification program in blockchain is a 4-month program. It's fully online and has a comprehensive curriculum that covers a broad range of skills. We'll show you that in a moment. It includes the integrated labs and hands-on projects that give you direct experience with the various tools and platforms, and let you build up a portfolio of those examples to show off to potential employers or to your current employer. But it also gives you the ability to do online live virtual classes so that you're interacting directly with instructors, you're answering their questions and asking their questions live, and you're interacting with your peers. The platform gives you 24/7 support so that you're able to do your work pretty much on your own schedule, with the exception of the scheduled classes, which are at given times. But other than that, any of the other project work or other preparatory work you can do anytime, day or night. And so it's flexible to fit your particular schedule. So, Professor, if you could go help us go through this step by step, just really briefly,
Yeah,
starting with the
so
orientation.
the program, starts with the orientation. Then first thing is to understand what blockchain is, and Bitcoin being the first blockchain, understanding that is important. And then you understand Ethereum, because you have to understand smart contracts. You have to understand the basic fundamental tenet of blockchain technology, how it achieves consensus. And then you go into permission blockchains. Like these two are permissionless blockchain. So Hyperledger Fabric as the primary example of permission blockchain. Then we learn more about smart contracts and networks, and then applications, and then you do a capstone project, which would actually allow you to really do something, palpable, a project that you can actually write in your resume. That I have done this kind of a project with blockchain technology. And then on top of this, so these are actually live classes that on the weekends, Simplilearn has specialists who are offering these classes. And then from IIT Kanpur, we do monthly master classes, which are not fully necessary for completion of the getting your certificate, but which are highly recommended to attend to get more insights into the blockchain technology and what's new going on in blockchain technology and so on.
Yeah, and since they're included in the price of the program, we always recommend people to take those. This is a program that requires you to have a bachelor's degree with 50% marks or higher. So when you apply for the program, we'll verify that. You do need to have a basic understanding of mathematics and a basic understanding of programming, as the professor said. So you do have to have some background there that will help you understand the course material, and there will be part of the evaluation when you apply. We'll cover that as well. But you don't have to come into this with work experience of any type. So this is something that you can come straight out of school to do. But you do have to have a bachelor's degree. Just a quick question for you in the audience. How much experience do you have? We'll just leave this open for about 15 seconds. And I'll close this in 5 seconds. Get your answer in. Here we go. So about half of our audience are people who are currently working on their degrees, but the other half are people who are in the working world. And so if you're about to finish your degree, you're probably eligible for the program. And if you're in the working world with a degree already, then you should be eligible, provided you meet the other background requirements. One other aspect of the program that I want to mention is that Simplilearn, we're the delivery partner, as the professor mentioned, and we provide the platform. We also provide job assist for learners in India. So if you're learning from India and are eligible to work there, we provide you with 6 months of job assist after you finish the program, so that you get access to expert webinars and career events and of course, your portfolio projects, but you also get formal access to IIM Jobs Premium Job Board, their resume rewrite service that helps you craft a resume that will not only get through the AI bot as the first step of a screening process, but also catches the eye of human beings who will see it after that. And then also interview prep service that will prepare you for the different kinds of interviews that you pass in order to get a new job. So with that said, I'm going to ask this two-part question in two parts. And first question I'll launch now, which is, are you interested, based on what we've shared with you so far, potentially in joining this program? Just leave that open for another 5 seconds. It's yes or no question. We'll close that now. So about 2/3 of our audience are interested. And so for those of you who said you are, oh, it's not launching this poll. Not sure why. Hold on a second. Hold on. Give me just a moment here. Get this fixed. See if I can get this poll launched here. One moment. All right, let's see if this works better. Oh, I see what the problem is. I apologize. User error. So yeah, if you are part of that 2/3 who are interested, how soon would you like to do this? We run different cohorts of the program fairly frequently, but they are limited in size. So in order to be able to give sufficient attention to each cohort, we try to limit it to about 25 to 30 people, so that the instructors can give enough attention to each student. So here we end the poll, share the results. Half of you would like to get started right away, and let me share with you how that works. Very quickly. So the next cohort starts this week. If you want to get started as quickly as that, the program fees are $1,69,000 in total, which can be EMI financed for $57.51 a month. But your bonus offer, as we mentioned, for attending this webinar, if you enroll right away, you can get 20% off of the program fees. Our bonus offer to you for it being here tonight and attending this information session. So reach out to us at askus@simplilearn.net, and we will provide you with the process to get started and help you get enrolled. If you would like a proof of attendance for being here tonight, or if you want us to reach out to you proactively, please let me know by answering yes here. Just about at the end of our presentation. So I'll leave this open for 5, 4, 3, 2, 1. So just under half of the respondents said yes. We will be contacting you by email after this session in the next day or so. And I want to thank Professor Shukla for being so very generous with his time, with his knowledge and his expertise, his very unique perspective on blockchain from his position with the national project.
Thank you. Thank you, Stuart. And thank you, everybody, for joining in. and hope to see you another time.
Yep. We hope to welcome you all into the learning experience with IIT Kanpur and Simplilearn. Again, I will put right into the chat the email address and the link to the program page so that you can get started if you're interested in doing that right away, or so that you can get more information to help you make your choice. And so if you take a look in the chat, you will see the email address and the URL link. So I'll give you about 15 seconds to take that information out of the chat. In the meantime, again, thank you all for being here this evening. Be sure to contact us to claim your bonus if you want to get enrolled. And with that, that concludes our webinar. Thank you all for being here and have a great evening.
Thank you, Stuart. So have a nice day, and I'm going to go to sleep.